Welcome back to the unit on proportional relationships. Today we're going to compare relationships on graphs. And we're going to compare related relationships, meaning that we would look at graphs of, say, two cars, looking at their miles per hour, their speed, or we could look at two graphs looking at prices of fruit in two different stores, but we wouldn't compare a speed of a car and the price of bananas on the same graph. It has to be related. And we'll also be able to tell after today's lesson, just by looking at two lines, which one has the greater constant of proportionality. So let's go back to the example we used in a previous lesson where we looked at Tyler at the boardwalk, and we're looking at meters per second, so meters per second, and the seconds are in the x-axis, and Tyler travelled 50 meters in 40 seconds. So I could simplify that down to 5/4 or 1.25 meters per second. And he goes with his friend Lynn, and Lynn travels 50 meters in 20 seconds. And if I get her unit rate or her constant of proportionality, 50/20, 5/2, she's travelling at a speed of 2.5 meters per second. And let's draw the graph representing Lynn's trip. So she's going for 20 seconds, and I'm going to go up to 50. And I'll fill in one more point to make it easy for me to draw my line. So 10 seconds would be 25 meters, and now let me draw my line. And we can see that Lynn got there in 20 seconds. It took Tyler 40 seconds, so Lynn gets there more quickly. So Lynn wins the race. And let's look at a few more features of this graph. The seconds is on the x-axis, speed is on the y-axis, the meters is on the y-axis, should I say. And Lynn's meters per second, her constant of proportionality, 2.5/1, is greater than Tyler's constant of proportionality, which is 1.25/1. And the line representing Lynn's journey is steeper, and then the line representing Tyler's journey, his is less steep than Lynn's. And the steeper line represents the greater constant of proportionality, the quicker she runs. So that's a feature we can look for in other graphs as well. So let's look at the price of blueberries in two stores and which store sells at the higher price. So let's look at 1 pound weight at two stores, A and store B. So 1 pound, and let's look at their prices. So store A sells for $6 per pound, I can see from the graph, and store B sells for $4 per pound. So the higher price is store A. And let's look at the constant of proportionality. So A, $6 per 1 pound, where the pounds is in the x-axis. So the constant of proportionality is 6. And store B, $4 per 1 pound. So the constant of proportionality is 4. And we can see that the greater constant of proportionality, 6, is greater than 4, has also got the steeper line. The line representing store A is the steeper line. So the steeper line represents the greater constant of proportionality when the denominator is represented by the x-axis. That's pretty important. Let's look at another example. So here we can compare graphs without numbers. Which asteroid is traveling more quickly? So which asteroid has the greater constant of proportionality. The greater constant of proportionality, or the steeper line, is asteroid X. So asteroid X. And let's prove that. Let's pick some random time. I'm going to just pick here, say, and go up along. And let's look at their distances travelled. So Perseid got this far, and asteroid X got this far. So asteroid X went a much further distance in the random amount of time we chose. And so it has travelled the greater distance. And so I'm going to write here asteroid X. And it has, looking at the graphs, the greater constant of proportionality and the more steep line. And we have distance per time, and the time is in the x-axis. So let's look at another example without scales. So here, if we look at this graph, we can see that we've got cost, which is P, the price, is on the y-axis, and the length is on the x-axis. So the length is on the x-axis. So if we were asked the price per the length, we could pick some random length, and we could see that the cotton has the higher price, because we're looking at price per length, and the length is in the x-axis. Cotton has the higher price, nylon has a lower price. However, that's not what we're asked. We're asked if you had $1 and you went into a store, which would you get more ribbon? Which ribbon would you get more of, the nylon one or the cotton one? So let's start over, and we can't just look at steepness of lines because we're not looking at price per length. We are looking at length per price. We're looking at length per price. So I'm going to pick a price, say here, and look at my length of cotton, which goes to here, and my length of nylon, which goes to here, and I can see that the nylon is longer. So we couldn't look in this example at the steepness of the line because price was not on the x-axis, it was on the y-axis. So if I redrew my diagram, where I had length was on the y-axis and price was on the x-axis, now I can see that the nylon is the steeper line here, and I can see that the price for the nylon is less than the price for the cotton. So then you get more nylon for your dollar. You get less cotton. This is cotton. So the steeper line represents the greater constant of proportionality, when the x-axis represents the number in the quantity in the denominator. So if we're looking at distance per time, as we are in this graph here, the greater distance, which is on the y-axis, is the steeper line. And that's the end of today's lesson.